Let's talk about distributions. Now, first off, what is a distribution? Really, a distribution is just a way to handle numbers. Now, there are 5 types of distribution available. There are constants, uniforms, constant curves, uniform curves, and parameters. Though you should note that all 5 of these distribution types exist for float and vector data types. So in the end, you'll have a float constant, a float uniform, a float constant curve, etc. Now let's go one by one through each of these. A constant, what is it? A constant distribution will provide a single number that does not change over time. So an example would be something like 13.7, which could be positive or negative. And for a vector, it would be a value for x, y, and z independently. A uniform distribution allows the user to specify a range of values. Each time the distribution is called, it provides a random number from within the range. An example for a float would be something like negative 30.055 up to 18.925. And for a vector, you can see we've got a minimum value for x, y, and z, and a maximum value for x, y, and z. And each time we called on that distribution, some number would be chosen from within that range. Now, it should be noted that in the case of a vector, a random number will be chosen independently for each of the 3 axes. Moving along, we have constant curves. Now, constant curve distributions are values plotted as points along a curve, which allow for a value to change over time. And it's important to note that the interpolation between these points can be edited in a Bezier tangent fashion. There's actually a curve editor inside the Cascade particle editor that we can use to edit these curves if we desire. And here are some visual examples. So you can see on the left we have a float value, which is a single number graphed between 3 points that slowly sweeps up. And then for the vector, we have 3 curves that are separated. Now, curves will not always be separated like this. They've just kind of been pulled apart for the case of an example. Sometimes they'll stack right on top of each other. Now, next we have a uniform curve, and this is a little more complex. Uniform curve distributions allow each point of a curve to be plotted within a min and max value. And as time progresses, a random value is going to be selected from within that range. Now here's what this would look like if graphed out. For a float, notice we have 2 curves, a min curve and a max curve, and the shaded area in between would be the random area from which a value would be called. Now, an important thing to keep in mind is generally you would want to avoid using this distribution on anything that's going to be called on every single frame of animation, because that means on every single frame you're going to get a brand new random value. Now granted, it will be within a range, so there are certainly some uses for this, but generally speaking it'll cause a jitter. And then over in the vector side, you can see we have min and max curves for all 3 of the axes, and you can see a little bit of overlap there. Finally, we have parameters, and parameter distributions allow a value to be accessed and changed through Kismet or Matinee. And just a couple of examples, and these examples could really go in any direction that you can imagine. But for a float, we have a quick example of using Kismet to shorten the lifespan of a particle system, such as allowing the player to turn down the intensity of a gas flame. Or with a vector, you could use Matinee to change the initial size of a particle system, such as increasing the spawn rate of sparks as an animated laser beam cuts through an object. Now that's just a quick look at all of the different distribution types. Now let's jump back over to UDK for just a moment, and I'm going to open up our PS Fire. And let's just grab, it doesn't really matter which one, so many properties have a distribution on them. I'll jump into our spawn module, and we'll take a look at the rate again. Now notice under rate we have a distribution, and we can change that distribution at any time. If you take a look right at the end of the word distribution, all the way across the property, there's a little tiny blue arrow button. It says create a new object, and this gives you access to all of the different types of distributions that you can apply to this property. So you're not limited to just using a float constant. If we wanted, we could take the spawn rate and give it a min and max value by applying a uniform, and then we'd have a random variation. So that's a quick look at distributions. As we work through the various modules for our particle system, we're going to be changing distributions a lot and setting their values. So now you know how they work, and that's going to wrap things up for this video.